section 5.7, our objective, I can simplify complex fractions. Well, first of all, what is a complex fraction? This is one where we have fractions within fractions. The numerator and or denominator have one or more fractions. For example, if I have 3/4 minus 1/8 divided by 2 plus 1/12. This would be considered a complex fraction because notice that the numerator has two fractions in it and the denominator has one fraction in it, right? And so the goal here is to clear out the fractions. So what we do is we look at the denominator of each fraction and we determine what would be the least common multiple of those denominators. So 4, 8, and 12, the least common multiple is 24. So what we do is we take and we multiply the whole numerator by 24 and we multiply the whole denominator by 24. So if I distribute in the 24, I get 24 times 3 over 4 minus 24 times 1 over 8 over 24 times 2 plus 24 times 1 over 12. So here I can take this and notice what will happen is that 4 goes into 24 6 times. So what I really have there is 6 times 3 or 18. If I go to the next one, I see that 8 and 24 reduce because we make the 24 over 1. 8 goes into 8 once, goes into 24 3 times. Okay, so I have 3 times 1. So notice what's happening here is that the denominator of each fraction is gone. So in the numerator here, I have 6 times 3 minus 3 times 1. In the numerator, in the denominator, if I take that, I have 2 times 24, or 24 times 2, plus, then if I look here and make that 24 over 1, make it into a fraction, this goes into 24 2 times, so I have 2 times 1. Notice what happens now is now I've gotten rid of the fractions within the fractions. So then I do 6 times 3 is 18 minus 3 times 1, which is 3, over 2 times 24, which is 48, plus 2 times 1, which is 2. And then I just continue simplifying. 18 minus 3 is 15. 48 plus 2 is 50. Then 15 and 50 both have common factors of 5. So I divide this by 5, this by 5. And so I'm left with 3 over 10. So the complex fraction simplifies down to 3 over 10. Okay. Example 2. Let's look at one now with variables. So I have r minus 3 plus s minus 3 all over r minus 1 plus s minus 1. Well, first of all, remember that a negative exponent really means a fraction. So let's first change each one of those into a fraction. So r to the negative 3 really means 1 over r cubed. S to the negative 3 really means 1 over s cubed, all over 1 over r to the 1 plus 1 over s to the 1. Right, now notice that what we have is a complex fraction. So we look at each denominator. We have an r cubed, an s cubed, r to the 1, s to the 1. So the least common denominator, or least common multiple of all of those, is going to be r cubed, s cubed. So what we do is we take and we multiply the whole numerator times r cubed, s cubed, and the whole denominator times r cubed, s cubed. So I distribute that inside. So I distribute here and here. So I get r cubed s cubed over r cubed plus r cubed s cubed over s cubed all over r cubed s cubed over r plus r cubed s cubed over s. Now I come back and I simplify this. So notice that the r cubes canceled and it just leaves me the s cubed. Then I simplify this rational. Notice that the s cubes cancel and I'm just left with the r cubed. In the denominator, we have an r that cancels, so we're left with r squared s cubed. And in the second one, we have an s that canceled. So that leaves us an s squared. So when I simplify that, I have s cubed plus r cubed all over r squared plus s squared. Okay? And then we really should see if that, I'm sorry, I did that wrong. I forgot the rest of it. It's r squared s cubed plus r cubed s squared. Now what we have to do is we have to factor to see if it reduces. This is sum of cubes, so remember that factors a is s, so it's going to be, and b is r, so it's s plus r. Then it's s squared minus sr plus r squared. And in the denominator, the common factor is going to be r squared s squared. Oops. R squared s squared. And that leaves us with an s plus r. Then reduce. This reduces with this. And so our final answer is s squared minus sr plus r squared over r squared s squared. Okay. All right, moving on, example 3. So here I have 1 plus 3 over x plus 2 over x squared all over 1 plus 2 over x. Now remember, this is 1 over 1. So remember, first step, look at the denominators. And let's go ahead and write this other one as over 1. And the least common multiple of 1x and x squared is x squared. So I'm going to multiply the whole numerator by x squared and the whole denominator by x squared. So if I distribute that, I get x squared times 1 over 1 plus x squared times 3 over x plus x squared times 2 over x squared. And in the denominator, I get x squared times 1 over 1 plus x squared times 2 over x. Now remember also that these x squareds are really over 1. Alright, then coming back to this, nothing reduces, so it just leaves me x squared. Then coming to this one, this x reduces with this and just leaves me an x, so that's plus 3x. Then coming here, this reduces with this, so that leaves me a plus 2. In the denominator, I get, combine this, I just get x squared, plus this reduces with this, gives me 2x. Next step is to factor. So we need to know what multiplies to 2 but adds up to 3. And that's going to be a 2 and a 1. So it's going to be x plus 2, x plus 1. In the denominator, there's a common factor of x. So it gives us x plus 2. Reduce. And that leaves us with x plus 1 over x. And that is our final answer. Right? And one last one, number 4. I have k oops, I have k plus 1 over k minus 2 over k squared over k minus 2 plus 1. Okay, first let's change everything to fractions here. Second, let's put these in parentheses. Then looking at each denominator, the least common multiple is going to be k minus 2. So we're going to multiply the whole top by k minus 2 and the whole bottom by k minus 2. So if we distribute, we get k minus 2 over 1 times k over 1 plus k minus 2 over 1 times 1 over k minus 2 over, and all I did here was distribute to each one. And on the bottom I'm going to distribute this, so I have k minus 2 over 1 times k squared over k minus 2 plus k minus 2 over 1 times 1 over 1. Now go back and reduce. Okay, starting here, nothing reduces, so we have k times k minus 2 plus, then coming here, this reduces with this, so that leaves us a 1 over, then coming here, this reduces with this, so that just leaves us a k squared plus, and here nothing reduces, so all I have is k minus 2 left. Okay, then I go back and distribute to get rid of these parentheses. It's going to be k squared minus 2k plus 1. I'm going to distribute the 1 that's here, k squared plus k minus 2. Right? Factor k minus 1 times k minus 1 over k plus 2 times k minus 1 is what each one of those factors to. What multiplies to 1 but adds up to negative 2. What multiplies to negative 2 but adds up to positive 1. Okay, that's where that came from. These reduce. And so we have k minus 1 over k plus 2. That's our final answer.